normally we're going to have quizzes like the first day back after the weekend, right? And you know that those quizzes are going to start with like some of the 10 a week questions, and then the last little bit will be like recent skills, okay? So kind of keeping in mind what those recent skills might be. But on top of that would be the 10 a week questions, okay? You guys are also going to hear me talk about grit a little bit. People that have had me before, I love the word grit, particularly for this class, because grit is passion and perseverance for long-term goals, and it's all about working really hard. The most successful people in life are the people who work the hardest. They're not the people with the highest IQ, okay? So just because you're smart doesn't mean you're going to be successful. So when you think about Angela Lee Duckworth's research on grit, it actually tells you that effort counts the most in terms of achievement. Like you can have a high IQ, but if you don't actually work for it, you're not going to develop the skill. And if you don't take that skill and put more effort into it, you're not going to achieve anything. In Math 30-1, you can't achieve much without effort. I'm just telling you, this is the kind of course where if you don't put a whole lot of effort in consistently, and if you don't show up for yourself regularly, you'll fall behind really, really fast. Okay, and I know I've kind of started off slow. You guys have no idea how fast this gets. Like when I hit trig and I have to start moving way faster, you've got to start learning faster. You've got to start working harder and faster. So quick question, something to think about. How much time do you work on homework each evening? If you're someone who had a really strong foundational skills from 20-1, it might take you 20 minutes to do homework because you've got the foundation set. If you struggled in 20-1, if you don't have like that really strong foundational knowledge, you might find that it's going to take you like 40 minutes or even an hour because you have to try to rebuild those skills. So just make sure that your study habits are strong and make sure that your study habits evolve from grade 11. You need to do more to do as well. Does that make sense when I say that? Okay, so there's your little message on grit. Now, I told you guys, I think I told you guys, that I will give you guys one bonus mark in every unit exam. You've got 5 unit exams, right? And those 5 unit exams are usually out of 25 marks. If you want to get a bonus mark on the unit exam, you have to create quality study notes and submit them to me the day before digitally in Google Classroom. So if your test is out of 25, and I'm saying I'll give you a bonus mark, that's like throwing 4% at your test mark. That's a huge difference. 4% could be like a make or break into university admissions. You guys get that, right? So what do you have to do? You have to not only fill in the blank notes and do your homework and do the 10 a week, you actually have to create study notes. I'm going to help you guys develop those study notes today. But before I do, I want you guys to take out your 10 a week because I did get some questions from your classmates regarding the 10 a week. So everyone got their 10 a week last week. And 2, 7, and 9 were the questions that were directed to me. Is there anything beyond 2, 7, and 9 you guys want me to address? So your 10 a week is in the basket. Did you get it? Perfect. Okay. Now, guys, I usually post the PDF of the 10 a week too, so you can always print it on your own so you actually can do it on the weekend. You don't have to wait till Monday. And the reality is you want to do it on the weekend because, you know, your quiz is usually going to be on a Monday. When you're taking apart this question, it says the function f of x is equal to x minus 3 times x plus 5, and it has 2 zeros. Now, I shouldn't have to put the word x-intercepts behind that. You guys should know from grade 11 that zeros would be x-intercepts, right? Like that sounds familiar to you guys? Yeah? Okay, so when I say x-intercept, what should you be thinking? As soon as you see this word, like you have to take apart the question and you have to interpret what's happening. When I say the word x-intercept, what should be popping into your head? What should you be thinking? Say it louder. Y equals 0. Okay, guys, if you weren't instinctually thinking x-intercept means y equals 0, you need to from this point on. That's something like your thought process has to go there. Now, if I wanted to put 0 in for y here, now you could have typed f of x into your calculator and use the zeros feature on your calculator to find the x-intercepts. Like that was a totally legit move you could have made. But from grade 11, you should know how to find the x-intercepts Like when I substitute 0 in for y, where do you go from here if I wanted to algebraically find the x-intercepts? These are called linear factors because they're degree 1 factors. We set each linear factor equal to 0 and we solve for x. And I know you guys, like some of you guys didn't take math, like you were in math first semester last year, which means you went a whole year without math. This is not fresh, and I wouldn't expect it to be fresh. So I've got this x-intercept of 3 and 0 and negative 5 and 0. So now it says, okay, this function has these x-intercepts. F of x goes through a vertical stretch about the x-axis by a factor of 2 and a horizontal translation of 3 units to the right. Guys, what would the mapping be for that? If I'm going to vertically stretch by a factor of 2 and horizontally translate 3 units to the right. Like a vertical stretch by a factor of 2 is actually the a value, and a horizontal translation 3 units right is actually h. So if we wanted to look at this in terms of like the transformation equation, a vertical stretch by a factor of 2 would be your a value, and then your h would be x minus 3. Do you guys agree that that would be the equation to represent those vertical descriptions? Okay. What would the mapping be then? If it's a vertical stretch by a factor of 2 and a horizontal translation 3 units right, what would the mapping be? The word vertical is telling you to change the y's. The word horizontal is telling you to change the x's, right? So if you're going to set up your mapping rule, 3 units right is x plus 3, and then we have 2y. Tomorrow you're going to have your quiz. If you can set up your mapping, mapping is the key to success. Like it's full on, like the best thing you can do for yourself. I'm going to map these ordered pairs, and I'm going to see what happens to the ordered pairs after it undergoes this mapping rule. So 3 plus 3, 2 times 0. Can we stretch 0? 0 won't change when I multiply it by something. So this turns into 6 and 0. And actually, I know the answer now because there's only one of them that has a 6. But I'll keep going. I'm going to do the same thing for the negative 5 and 0. I'm going to map it. So negative 5 plus 3, and then 2 times 0 gives me negative 2 and 0. And it looks like my new zeros are 6 and negative 2. How did I know that they were still zeros or x-intercepts? The y was equal to 0, so these are still x-intercepts. Yeah? The next one we're going to look at is question number 7. So if you guys want to turn to question number 7. Okay. This was not my question, but I thought it was actually a really good question when it came out. This was like a diploma question once, and it was like your entry-level first question or second question on the test. And it says, given the function f of x below, which of the following transformations will result in the same line? Okay, so let's look at the options. This is one of the questions where you actually have to look at the options, and you have to do work for each of them to see which one is going to give you the exact same line. So when I look at this, I'm going to rewrite this. I'm going to isolate for y, and I see this. Describe the transformations associated with this function right here. What would the transformations be? Do you guys see horizontal translation left 1, vertical translation up 2? Okay, grab an ordered pair. Now notice, like the scale, like so this is negative 1, this is positive 1. Like it's not like every little box is 1, right? Like this is 3. So what we're doing is it says left 1, so left 1 and up 2. Do you guys see that we just landed on the same linear function? If I go left 1, which is what this is saying, left 1, up 2, I just land on this. Okay, so it looks like I'm getting the same line. like basically the ordered pairs that I'm moving are landing on top of other ordered pairs that are on the same linear function. Okay, so that's what it looks like for the first one. The second one would be left 1, down 1. If I go left 1, down 1, am I on the same linear function? So I take this ordered pair and I go left 1, down 1, am I landing on the line again? No, so definitely not this one, because we were asked to get the same linear function. They have to land on top of each other to be the same linear function. Do you guys get that? Okay. When I go through the next one, so when I isolate for y to see my transformations, this is going to be right 1, up 2. So if I go right 1, up 2, certainly not on the same linear function. And then the last one, and again, if you don't have every question tried on this, you've already given up on yourself and you haven't shown up for yourself yet. Like I gave you 10 a week and you got to show up for yourself and you got to at least try every question. So you're not truly like you're not bringing your A game to Math 30-1 yet. Don't let it happen again. Left 2, down 2, doesn't land on the line. So we know that this guy is out. Okay. Honestly, if I gave you 10 questions and I said do these questions over the weekend and you didn't show up for yourself, you're probably in the wrong class. I'm not going to lie to you. You got to have like 100% effort all the time. If I say something, you do it. Like if I say jump this high, you got to jump that high. Okay? You have to practice these questions. Okay, the last one that we're going to address is question number 9. Now this one was tricky, and the reason why this one was tricky was actually because we just talked about this basically at the end of class last time. We talked about the only way that you can actually see the horizontal translation is if the b value is factored out. Okay? There's a reason why we have 2 sets of brackets. Now the other class is a little bit ahead of you guys, so they would have had more practice with this. They probably would have found it a little bit easier. When you look at the general expression for all transformations, you can't see the h unless you see 2 sets of brackets. That's the first detail to attend to. So here's our graph. There's 4 ordered pairs. And it says if this is f of x, then g of x was equal to, and it says bracket negative x minus 3, and then it says, and it'll be plus 4. Right now, I don't see 2 sets of brackets. I see a b and an h, but I actually can't see the h because I don't see the 2 sets of brackets. So the first move you have to make is you have to factor the negative 1 out. You start your brackets, and it's only when I factor the b value out that I can see the horizontal translation. And so remember, b and h are going to change your x's, and then the 4 is going to change your y's because that's your k value. So your mapping looks like this. Negative x, this is left 3, so it's going to be minus 3, and then y plus 4. And if you set up your mapping rule correctly, which is what you need to know for tomorrow's quiz, right? If we set up our mapping rule, we can grab an ordered pair like negative 2, negative 1, and we can map it. So it's negative of negative 2 minus 3, and then negative 1 plus 4. And this ordered pair is going to land in negative 1, positive 3. So it gives me the impression that, so negative 1, positive 3 would be right here. I think we're going to be Q2 with this whole function. I'm going to map the other or end point, so the 2 and 2. So this becomes negative 2 minus 3, and then 2 plus 4. And this ends up being negative 5 and 6. So negative 5 and 6 is way up here in quadrant 2. So the whole thing is going to land in quadrant 2. Yeah? Guys, if you just want to show up to class and take good notes and not do a whole lot of work at home, you're in the wrong class. That's 30-2. Like when I teach 30-2, I do everything I need to do in the class, and then I don't expect students to do a lot at home. If you think that you can just show up in this class and not do everything that I tell you to do, you have to change your class. You have to change your schedule, and you have to get yourself in a 30-2 class this week, because there can't be changes. So if you already in the first week haven't shown up for yourself in Math 30-1, go make a schedule change, because seriously, it won't go well, okay? If you want to just show up and take quality notes and then not do work at home, that's so not a -1 move. You have to do the work, okay? Tomorrow you're going to have a quiz. You should do the 10 a week, because I asked you to do the 10 a week, and it prepares you for your quiz, okay? And if you talk to any Math 30-1 student from last semester or last year, it is not like any other course. If you don't do the work, you will not set yourself up for success. Like, definitively, you will not. Okay? So, I did tell you guys that we were going to have study notes, and I will give you that bonus mark for study notes. So why don't we just start the study notes? Take out your homework books. Let's get started with the study notes. And then if you want to have those study notes next to you, you're welcome to do that. Take your homework book out, flip it upside down, turn it on its back side. So if I was going to do study notes for this unit, I would make sure all my, so you're going to have 3 homework checks that I'm going to be doing tomorrow. And again, if you don't even have your homework done, register for a different class. You're in the wrong class. Okay? This is not designed for people who don't do work at home. 30-2 is designed for that, okay? So your homework, you should already have the homework for 1.1 in here. You should have the homework for 1.2 in here. 1.3, I'm giving you tonight. You're doing it tonight, and I'm checking it tomorrow. It's a 1-day turnaround, okay? We don't have time to mess around. So your homework's in the front. You turn your book over on the back, and this is where you're going to put your study notes. If you want to get an extra 4% on every unit test, you're going to create quality study notes. Okay, so so just turn, like, I just flip it open. I keep the coil on the left. I don't care if it's upside down. Like, there's my book, it's upside down. I don't care. I'm going to put my study notes here, and the night before my unit exam, I'm going to make sure I've got quality, thorough study notes to submit so I can get that 4%. Okay, so this is unit 1, and it's transformations. That's chapter 1, and polynomials. So if you want like a textbook resource, so are my notes packages great? Are my completed notes great? Are the 10 a weeks great resources? Absolutely. But do you actually have worked examples in your textbook? Absolutely. And those worked examples are aligned with my notes package. So if you don't feel like you're getting enough, look at the worked examples in the textbook. Okay? We're going to start with chapter 1. Transformations. Now, what I'm going to do for you right here, and we did this last day, we actually did it was the first question on your 10 a week, and we actually filled it in. We're going to create a quick concept map for your future self. So when you really want to like review the whole unit, you go to your study notes and you review that whole unit. Okay, leave a couple of lines above and write down the one gift you get on your formula sheet, because you need to know how to interpret this in terms of transformations. Okay. What can you guys tell me about parameter A? There's 6 transformations. Last Friday we learned all 6 of them. We started working with all 6 of them. What do you remember about parameter A? Yeah.
If it's less than 1, it's a reflection across the x-axis.
Okay, if A is less than 1, we reflect across x-axis. Now, there's a couple of details that I want you guys to attend to. Just notice, like I said, keep a couple of lines and then go straight to the concept map. Here's something that gets people. The x-axis is actually the equation y equals 0. You don't have to write this down, okay? Like if you're, don't write this down actually. If this is your x-axis, it's where y is 0 and it's always 0 all the way across. So another way of saying like the x-axis would be the equation y equals 0. So that's a sneaky way that I could say x-axis without saying x-axis, is the equation y equals 0. So feel comfortable with that notation for the x-axis. And this reflection across the x-axis will be depicted by this notation. If you see this, this is just the shorthand notation for like, hey, reflect across the x-axis. What else did parameter A do? Yeah?
Proves above, if the value of A is above 0, it's going to be a vertical stretch across the x-axis.
Okay. We would just say, okay, so we'll say vertical stretch of, and I'm going to say absolute value of A because the negative sign did the reflection. The magnitude of A is actually the vertical stretch factor. So the vertical stretch of the absolute value of A is, sorry, can I erase that? I'm going to fix that. Vertical stretch by a factor of the absolute value of A, and you have to say from the x-axis. So don't write this down. Let's say I had an ordered pair of 2 and 1. If I reflected it across the x-axis, it would become 2 and negative 1. Yes? Okay? And then if I moved it, and then so reflection across the x-axis, 2 and negative 1. Vertical stretch by a factor of A from the x-axis. If I said a vertical stretch by a factor of 2, this would get multiplied by 2. And the distance from the x-axis would then double. Did you guys get your heads wrapped around that? The word vertical is telling you that it changes the y's. So your A value is always going to change the y's. What other parameter changes the y's? What other parameter is going to make it like direct, like it's going to change the y's? Yeah.
K.
K. Okay. So the K value, I'm kind of color coding this. This is your vertical translation. And it's direct. So if you see plus K, you're going up. If you see minus K, you're going down, right? So there's a vertical translation there. The word vertical is telling you it's making a change to the Y. So if you had 2 lines above, I want you to go to that second line above, and I want you just to kind of connect these two, and I want you to write change Y's. Okay, so the A and K, because the word vertical is attached to those parameters, those are going to change the Y values. So right now I've got 1, 2, 3 transformations. Now talk to me about the B value. What does the B value do? How would I describe the transformations attached to B? What happens if B is less than 0? Hey guys, if B is less than 0, we reflect across the y-axis. This sneaky way of writing y-axis is actually x equals 0. Now the notation associated with the reflection across the y-axis is this. So the shorthand, you need to know that this means reflection across the y-axis. When you're reflecting across the y-axis, your change is on the x, right? So if this is my y-axis, this is where my x equals 0. My change is happening on the x. It's a horizontal change. Now this one has a twist to it. We use the inverse. So this is your horizontal stretch. By a factor of, and it's always reciprocated. It's the reciprocal of B. The absolute value bars mean the negative sign did something else. So the stretch is actually without the negative sign. So the horizontal stretch by a factor of 1 over B, and that's from the y-axis. What this is going to do is it's going to pull the ordered pairs away from the y-axis and make the function either wider. Like if it was a horizontal stretch by a factor of 2, it would be twice as wide. If it was a horizontal stretch by a factor of 1/2, it would be half as wide. Can you guys imagine that? Okay, so these are attached to the word horizontal, so we know that that's going to make a direct change to the x. Now here's a twist that I need you guys to recognize, is the 2 sets of brackets. We need to see both brackets to see the h value. So what that means is we can't see the horizontal translation unless the b value's been factored out. Okay? So once we see the 2 sets of brackets, so the first thing you always want to look for is if you see a coefficient on the x and a constant inside the function, you better have 2 sets of brackets or else I can't see the horizontal translation yet. Okay, so I'll show you what that looks like. So this is going to be your horizontal translation. If you see x minus h, we're going to the right. If you see x plus h, we're going to the left. And by the end of this block, this should feel comfortable to you, and by the end of your homework tonight, it should feel like it flows. Okay, so you tried the 10 a week this weekend, you do the homework tonight, and you'll be ready for the quiz for tomorrow. So I'm going to give you guys a quick example. Oh, this is the other detail. These guys inside the brackets change change x's. I was reading y's. So the stuff inside the brackets are actually going to change the x's because you see the word horizontal, and the word horizontal is pointing you into the direction of, okay, that's an x value movement. So I'm going to quickly write the mapping. So your mapping is based on anything that used the word horizontal is changing the x's. So your mapping looks like this. Whatever, this is b. So in your equation, it becomes 1 over bx and then plus or minus h. If b was negative, it would be negative 1 over bx. That's all it is. Okay? And then it becomes ay plus or minus k, and that's it. There is an order. So when you're transforming functions, there's an order. The order has to be anything attached by multiplication has to be described first. Any stretches or reflections have to be at the top because they're attached by multiplication. Any translations happen at the end because they're addition and subtraction. And when you think about order of operations, brackets, exponents, multiplication, division, addition and subtraction. Addition and subtraction happens at the end. So your order, your top 4 transformations are going to be any reflections or stretches. And then we've got translations. Okay, so I'm going to give you guys a little example. So this isn't study notes. This isn't exclusively your study notes for chapter 1. Okay, this is actually in the notes package. This is just me transcribing what's already in the notes package. So if you're missing something, you can always go back to the notes package and add what you need. But what I want you guys to do is always offer yourself 3 worked examples. And you want to find the examples that you thought were tricky or examples you got wrong. So when you tried the 10 a week and there was a question you got wrong, what was it about that question that you got wrong, and learn from your mistake? Put it into your study notes so you don't make the mistake again. So here's my first worked example. If I give you this, I give you this. This is combining all of our transformations. When you approach this question, it should actually drive you bonkers the way it's written right now. Like you should be like, ooh, I can't see all my transformations right now. Why can you not see all your transformations? Ryan. Yeah, guys, we don't see two sets of brackets. I see a coefficient and a constant inside the brackets. I have to factor the b value out in order to see the horizontal translation. So my first move would be to factor out the b value. Positive 6 divided by negative 3 is x minus 2. And there's actually 5 transformations that just took place here. Are you guys okay? I'm just factoring. I'm getting the two sets of brackets by factoring. Let's not write down the verbal description. Let's just say it. What's the 2 doing for me? How would you describe the transformations? So let's say we're going from y is equal to f of x, and it's getting transformed in this way. How would you describe the transformations with the transformation attached to the 2? What would that be? Yep. Yeah, this is a vertical stretch by a factor of 2 from the x-axis. We just made the function twice as tall. We're pulling it away from the x-axis by a factor of 2. What does this negative sign do? Just say it. Like, you don't have to raise your hand, just say it. What is it? Reflection across which axis? This is a reflection across the y-axis. Now the magnitude of 3 is going to do something else. What's the magnitude of the 3 going to do? By a factor of what? 1/3. This is the one where we reciprocated. This one's the bugger because the x isn't isolated. It's actually the inverse. So we'd actually describe this as a horizontal stretch by a factor of 1/3 from the y-axis. It's the reciprocal of whatever you see in the b value. And then we see this. What's this? If it says -2, it's going to the right. If it says +2, it's going to the left. But do you guys see that a lot of people would say, oh, this is going left 6? If they don't factor the b value out, they're going to say that the horizontal translation is left 6. That's the most common wrong answer. You had to factor out the b value to see that the horizontal translation is right 2, and then the vertical translation is down 5. Now, what I need you guys to remember is these two change the y's, these two change the x's. So if I want to come up with my mapping, can you guys write the mapping? Now, the words you just used will be directly related to your mapping, okay? So this is my b value of -3. The way I use it is I put -1/3 in, attached to the x by multiplication. This is my reflection across the y-axis. This is my horizontal stretch by a factor of 1/3. I just made the width 1/3 the width. Is that okay? And then if I'm going to go right 2, it becomes +2. And then these impact the y's, and they're direct. There's nothing tricky about the y values. Done. Okay? So the words, the mapping, so the words are you describing what you're about to do. The mapping is you doing it. So when I said horizontal stretch by a factor of 1/3, the 1/3 goes into the mapping, so that's me doing it. Does that make sense? What you want to do now is you want to add a couple more examples from these 3 lessons that you found tricky in the notes. If you just give me the stuff I give you, you're not going to get the bonus mark. You have to supplement what I've given you in your study notes with stuff that you found was tricky. Does that make sense when I say that? I'm not just giving you 4%, you're working for 4%. Okay? And the reason why is because I have students at university who are like, Mrs. Secure, I'm still using my study notes. Like, I had a student email me, like, he was at engineering, he had a scholarship at U of R, and he was like, Mrs. Secure, all of my calculus study notes and all of my 30-1 study notes, I use them all the time. So, just kind of keeping in mind that, like, you're going to use this stuff. It comes with you. I had a student who got a math degree from University of Waterloo. She sent me emails like years later, and she's like, I'm still using my notes from Math 30-1, so thank you. If you guys create solid study notes, you're going to set yourself up for success. I know that we didn't actually finish task 13. So can I get you guys to turn to task 13? The other class is a little bit ahead of us, and so you probably will have a little bit less whiteboard work than they will today, but that's okay. Okay, get you guys to type in f of x into your calculator? We had actually started talking about why the function looks the way it does. And it was the square root of x minus 1 plus 1. How about we'll do two quick examples. I'll send you guys to the whiteboards for a little bit of a warm-up, and then we'll get into 1.3. My goal is to get through all of 1.3. I got through all of 1.3 with the other class, so that's my goal, okay? Okay, why does your graph look like this? If I have y is equal to the square root of x minus 1 plus 1, if x minus 1 is greater than or equal to 0, then x is greater than or equal to 1. We know that there's restrictions on the variable. We can't square root negative numbers. So therefore, my domain actually starts at 1. If I had put 0 in here, I'd be square rooting negative 1 and I'd get an error. Do you guys remember how we kind of like connected this to stuff that we learned last year? If I put the 1 in here, 1 minus 1 is 0. The square root of 0 is 0. 0 plus 1 gives me 1. That's my start point. If I get greater than the 1, if I put a 2 in here, it'd be 2 minus 1, which is 1. The square root of 1 is 1. 1 plus 1 gives me 2. So there's actually a few ordered pairs right here. Okay. That's why the function looks the way it is. That's why I gave it to you in this way. At the very end of class on Friday, we talked about a vertical stretch by a factor of 2, because that's what this is. It says sketch the graph of g of x, and this would be a vertical stretch by a factor of 2 from the x-axis. We've got to pull the ordered pairs. We've got to double their distance from the x-axis. So when you look at this, here's my f of x. This was 1 unit. I need to double the 1 unit, and it becomes 2 units away from the x-axis. This distance was 2 units. It's now going to become 4 units away from the x-axis. This distance was 3 units. It's now going to become 6 units away from the x-axis. And this is what our new radical function should look like. Yeah? That's what a vertical stretch. You're pulling the distance, and that's why we have to say from the x-axis. You're pulling it from the x-axis. Don't say across the x-axis. The reason why we wouldn't say across the x-axis is because we're not crossing it. We're pulling it from it. Okay? So now it says state the domain and range of g of x. What's the domain? So this is my g of x. What's the domain of g of x? Yeah, it's still, so I'm going to get formal because we need to get the formal notation. So x such that x is greater than or equal to 1. X is an element of the real number system. Did anyone want to do it in interval notation? If it was interval notation, you would have said 1 to infinity. Yeah? Okay. What's the range of g of x? That's the lowest y value.
2, sorry.
So 2, yeah. And then guys, I want you guys to notice this, commas, not semicolons. Okay, you gotta have a comma there. Okay, if I were to write the mapping notation, the word vertical implies I'm gonna change the y's. So your mapping notation would look like this. When you think about the ordered pair, like 1 and 1, did we double the y value to get 1 and 2? Absolutely. When I think about the ordered pair, 2 and 2, did I double the y value to get 2 and 4? That's the mapping, yeah? Okay, now if I want to write the equation for g of x, here's the twist, okay? If f of x is equal to the square root of x minus 1 plus 1, if g of x is equal to 2 times f of x, this is telling you have to take 2 times the whole function, not just the radical piece, okay? So when I look at this right here, 2 times f of x, if this is my f of x, then g of x is going to be 2 times the whole function, the radical part, and the constant at the end. This is your equation for g of x. And we had to go, like this was right 1 up 2. We knew that the start point was going to be right 1 up 2. So when you want to get a vertical stretch by a factor of 2, most people do this. And they leave the 1 alone. They just put the 2 on the radical and they think they vertically stretched this. It's incorrect because you're starting at the same point, okay? But you have to remember 2f of x means it's 2 times the whole function. And because my function was more than just the square root function, I had to take 2 times the whole thing. You don't break into the function, but you have to take 2 times the whole thing. And there's your vertical stretch by a factor of 2. Okay, let's try this one. Describe the transformation if my h of x, so if h of x is equal to f of 2x, how would you describe that transformation? Yep.
A horizontal stretch by a factor of 1/2.
Beautiful. Okay. Horizontal stretch by a factor of 1/2, and then it's from y-axis, okay? That means that the distance from the y-axis is now going to be half as much. So if this distance was 1, it's going to be half as much. If this distance was 2, half of 2 is 1. If this distance was 5, half of 5 is 2.5. The distance from the y-axis has to be half that distance, and this is your resulting function. This is your h of x. State the domain and range of h of x. Let's do it in interval notation this time. So the domain of h of x and the range of h of x. Are you guys okay that the x value actually starts at 1/2 and moves to the right? This would be inclusive 1/2, and then we go to infinity. That's interval notation. So if you would have said x is greater than or equal to 1/2, this is interval notation for the same thing. And then the range, nothing happened to the y's. It's just going to be 1 to infinity. Are you guys okay with that domain and range? What would the mapping notation be? Remember that the sentence is exactly what you're doing in the mapping. Like your sentence is the description, your mapping is you actually doing it. So if your description used 1/2, then the 1/2 goes directly into your mapping. Yeah? And then if I'm going to write the equation for h of x, if h of x is equal to f of 2 of x, this is telling you to replace x. This is saying replace your x's with 2 x's. Okay? So your f of x was originally this. If I want to come up with my equation for h of x, I just replace the x with 2x. I don't throw brackets in. Brackets can only happen when I factor something out. Okay? So right now I can't see the horizontal translation. unless the b value's been factored out. So I can't actually see that horizontal translation right now, but this is my horizontal stretch by a factor of 1/2, and this is what it would look like. So if I just replace the x with 2x, so just replace the x with 2x. Do you guys see that that's a horizontal stretch by a factor of 1/2? Now, if you want to get into the habit of seeing the horizontal translation, if you factor the b value out, you could see, I leave the radical, the 2 stays inside, that's where like, the radical is like your square brackets, and then this is saying start to the right 1/2 and up 1, right 1/2, up 1, and that's your start point. That got a little tricky. So I'm just showing you that there's 2 different ways of writing this. There's the just replace the x with 2x. If you want to add brackets, you'd have to perform the factoring to the double set brackets. Okay, that was homework that I assigned on Friday. I'm going to send you guys to the whiteboards. Remind me, because in the other class I started the recording. Okay. Guys, we've built the concept map a few times. By now, and definitely by tomorrow, you've got the order of transformations like memorized. You've got the transformations attached to each parameter memorized, and you've got the connection to the mapping memorized. Okay? Now, in terms of descriptions or transformations, you guys have to know how to use them. But truth be told, if you can set up the mapping, like 90% of the questions, if you can set up your mapping, you can get the right answer. The mapping is telling you what to do and how to do it. So mapping is the key to success here. So if we've got a function f of x, how would you describe the transformations happening here? We just did these at the whiteboards. Can you try these two? All I want you guys to do is give the verbal description of what's happening, and if you can turn it into mapping, that would be great too. Do you guys see that it was parameter a and k? Like this is outside the function, this is outside the function. So just once you're done these 2 questions, just look up after you're done them. And the words by a factor mean that you're multiplying. Okay. Guys, what's your mapping going to look like? Is there any change happening to the x's? Nothing. Leave your x's alone. The only transformations that are being applied are on the y values. That was supposed to be vertical translation. Did you guys catch that? They're both vertical, so they're changing the y, so it would have been 1/2 y and then -2 if you had the mapping as well. What's wrong with this one? Like, why does this one actually, like, it actually makes the hair on the back of my neck stand up because it drives me crazy looking at it. Because it is, like, limiting me in terms of this, like, being able to see my transformations. What's wrong? There's a coefficient and a constant all stuck in the brackets together, and they don't belong together. The coefficient and the constant need to be separated by the process of factoring. We need to see the 2 sets of brackets to see the full transformations. Right? So you have to factor the b value out. The b value doesn't come outside the function. It's still stuck inside the function, but you start your square brackets. Positive 10 divided by negative 2 is actually negative 5. Now you should have 1, 2, 3, 4 transformations. start from the beginning. If you start from the beginning of the function and you start listing your transformations, you're going to get them in the right order, right? So describe the transformation on the 4. Describe what the negative sign on the 2 is doing. Describe what the 2 is doing. Describe what the 5 is doing. The negative sign is on the B. Which reflection is that? Reflect across the x-axis or reflect across the y-axis? Which one is that? If B is less than 0, which one is it? That's a y-axis reflection, right? This is the twist, the horizontal stretch. Guys, what's my horizontal stretch? By a factor of, what is it? 1/2. People mess that up all the time. And then you have to say from y-axis. The vertical stretch made it 4 times taller. The horizontal stretch made it half as wide, right? And then we've got the horizontal translation. Right or left? Right? Okay, if I were to write the mapping, remember that A and K change the Y's, B and H change the X's. What would your mapping be? And I know I didn't actually ask you for it, but what's the mapping here? Reflection across the y-axis is going to be a negative sign directly attached to the x. A horizontal stretch by a factor of 1/2 means it's just going to be like, just take your b value and multiply it by like 1 over b. And then if I'm going to go to the right 5, it becomes plus 5. And then my vertical stretch is just 4y. Everything outside the function changes the y's. Everything inside the function changes the x. And the key to success is all in the mapping. Okay, guys, try this one. Use mapping to show how the transformations are going to take place on this guy. What's wrong with it the way it is right now? Why is this bothering you? Why should this be bothering you? What's wrong? Yeah. So we need to factor it out. So see it as like a -1 that you're factoring out. So when you look at this, this is 2f square bracket -1. Guys, you wouldn't stretch something by a factor of 1 because 1 times anything is just itself. If you want to put a negative sign, you could. If you want to put a -1, you can. But it changes the sign. The +3 turns into a -3. So the most common mistake people make is they leave this +3 in here and they interpret it as left 3 when it's actually right 3. Do you guys see that? What's the mapping going to be? What's happening to the x's? -x +3, 2y -1. They just said, what's the mapping? So we just need to do the mapping. We're just looking for the mapping here. Okay, we're just going to do a few more tasks, then we got to take it to like the big picture. So guys, this is a cubic function. So on your formula sheet, you get this. And this is a rule for all possible functions. If I know it's a cubic function, I ditch the f and I put the cubed outside the square bracket. So if it's a cubic function, the a would be outside. You ditch the f because we know what function it is. So that's supposed to be a b. So I've got my a square bracket b x minus h. And instead of it being a universal rule for all functions by putting an f in there, I know what function we're dealing with, and it's a cubic function. So I ditch the f and I make it a cubic function, and the cube has to be outside the square brackets. Okay? So let's ignore the fact that it was a cubic function. What parameter would be a vertical stretch by a factor of 3? And it should say from the x-axis. Guys, which parameter would be a vertical stretch by a factor of 3 from the x-axis? Which parameter is that? A, B, H, or K? A, so that's going to be an A. And then if I'm reflecting across the y-axis or in the y-axis, which parameter would that be? Is that A, B, H, or K if I'm going to get a reflection across the y-axis? That's B. If it's going to be translated 2 units left, that's H. And if we're going to go up 4, that's K. So we have y is equal to, my A value is 3, and I'm just going to do general expression F. If I want a reflection across the y-axis, I know my B value has to be negative. And then we're going to the translation. If I want to go left, it's going to be x plus 2. That's left 2. And then up 4. Because it was cubic, I need to ditch the f, and I need to turn this into a cubic function. The cubed function goes outside the square brackets, and that's how I basically interact with the equation. I mean, f is the universal rule for all. We didn't want all, we wanted cubic. Does that make sense? So you replace the f with your cubed outside the brackets. Okay, guys, let's take a look at this guy. We're starting with the graph of f of x. So it says the graph of y equals g of x shown represents the transformation of the graph y equals f of x. This is my f of x. This is my g of x. Yes? Determine the equation of g of x in the form. So there's my transformation. And then explain your answer. Okay. See that my original function was 8 units wide. Okay, when you think about these, we always have to think about stretches and reflections first. Do you guys see that our V is still opening up, so there's no reflection? And do you guys see that if I reflected across the y-axis, it would land on top of itself, so we're not going to describe a reflection across the y-axis. That would just be extra and not necessary. I can see that this width was 8. And then the new functions, we have to do stretches first, don't do translations. My new function has a width of 2. Which transformation would make that happen? How would you describe that transformation? Yeah, right.
Horizontal stretch by a factor of 4.
Okay, so it's basically, it's a quarter, right? Like, if you're thinking divide by 4, that's the same as multiplying by a quarter. So if I say horizontal stretch by a factor of 1/4 from y-axis, okay? If I use those words, what's that going to look like in my equation? Like when I'm thinking about like y is equal to a f b x minus h plus k, what parameter do I have? Marion, what do I have?
B.
What's b?
4.
B is 4, right? So right away my b value is 4. In the function, we take the reciprocal, right? So I've got the b value of 4. Now, let's look at the height of the function. This guy has a height, so it's 4 high. The new function is 8 high. What transformation would that be? What would that be? If I'm gonna take the height, it was 4 units high, and I'm gonna change that height, I'm gonna turn it into 8 units high, which transformation would that be?
The vertical stretch by a factor of 2 from the x-axis.
Okay, guys, that's your vertical stretch by a factor of 2. Those are the tricky ones, is to it's to recognize, oh my gosh, I got so much narrower. And I got narrower by a factor of 1/4, which means my b value must have been 4. Oh my gosh, my whole function got stretched. It's vertically stretched by a factor of 2. So then my vertical stretch by a factor of 2 would be an a value of 2. And then the last detail that we attend to is, okay, well, this corner looks like it was moved. Right now, we've made it narrower and we've made it taller. So like right now, your function is like looking like this. We've horizontally stretched it by a factor of 1/4. We vertically stretched it by a factor of 2. Now we've got to translate it. I'm going left, how many? Do you guys see the left 7? Which means we're going to have x plus 7 here. And then the vertical translation up 2. So then plus 2. Does that look okay? And then this, and I should probably box it. There was a lot of work that went into that. So I'm just going to box this. Can I get you guys to take the words and put it back into the equation for these two? Just kind of get one step ahead of me. Did you get your b value correct? Did you put it back into the function correctly? If it's a horizontal stretch by a factor of 1/4 from the y-axis, then your b value in the equation should have been 4. Not 1/4. The mapping would have been 1/4, but the function, that's your b value. It's reciprocated. Make sure your reflection across the y-axis is outside. You want to see the 2 sets of brackets, just like the formula. You've got your square brackets. The b value is outside the round brackets, and then your horizontal translation left 2 would be plus 2. Yeah? Now this last example that I'm about to give you, this is the level that you need to get to for the quiz tomorrow. Okay? You need to map a whole function. You need to transform a whole function, and the function is going to come at you in a way where the b value is not factored out. Now the tricky thing, your first interpretation when you look at this, so here's your given f of x, and it says sketch the graph of a transformed function here. When we look at this f of x, guys, what's the b value? B is supposed to be attached by multiplication. To divide by 2 is not a b value. Division is never a parameter, a, b, h, or k. What would the b value be if I'm dividing by 2? You have to kind of see that there was a sneaky coefficient of 1 on the x. So your first interpretation of this would be to recognize that the b value is actually a 1/2. When you're dividing by 2, you're actually multiplying by 1/2, and we need the b value to be attached by multiplication. So you had to actually see the 1 and the 2, and you pull it out so it can be attached by multiplication. And that's your first step in the process, is to actually recognize that my b value is not 2. My b value is 1/2. Okay? Now what's wrong with it now? When you look at it now, why is it not quite where we need it to be yet? we have to factor out the b-value. So guys, we have to divide each term by the 1/2 to pull it out. We need to factor it out. So guys, what is 1 divided by 1/2? You could fire that into your calculator if you want. Or you remember that when you're dividing fractions, you multiply by the reciprocal. And what we end up with here, your b-value is still 1/2. Don't reciprocate it. We're just pulling it out. I should have had my square brackets. I just pulled it out. I just factored out the b-value, and I'm left with x plus 2 within the brackets, and then minus 4. So the first move is actually interpreting what the b-value is. The second move is to factor the b-value out to see the horizontal translation. Now, if you were to describe this, do you guys see that this is a horizontal stretch by a factor of 2 from the from the y-axis? We're making it wider. Horizontal translation left 2, vertical translation down 4. That'd be really hard to do on every ordered pair if we didn't have mapping. If you have your mapping is the key to success. And if you look at this, we've got 1, 2, 3, 4, 5 ordered pairs. We want to come up with a mapping rule and just apply that mapping rule to every ordered pair. And that's how you transform these functions. So when I look at this, my mapping rule, and if you get the mapping right, you're going to get this right. It's going to become, I'm looking at this guy, we reciprocate the b-value, so 2x, and then I know I'm going to the left 2, so it's going to be minus 2. What's happening to my y's? I'm going to take all my y's, I'm going to take them down 4. So I've established my mapping rule, and then I've got 5 ordered pairs that I need to map. I need to map -3, -4. I need to map -2 and 0. I need to map 0 and 8. I need to map 3 and 0. And guys, you can type this stuff into your calculator. You don't have to do the mental math. And then we got to do 4 and 4. So this is the rule that we're going to map all 5 ordered pairs, not just mapping one ordered pair anymore. So if I'm going to map these ordered pairs and I'm going to plot them, I'm going to plot them as I map them so I know how to connect them. Don't get all the ordered pairs and not connect them one at a time. So when I follow my mapping rule here, we've got 2 times -3 minus 2, and then -4 minus 4. And this becomes -8 and -8. So my new function is going to have the ordered pair -8 and -8, and I'm going to plot it right there. I'm going to follow the mapping rule again. Again, you could type this into your calculator, like 2 times -3 minus 2, right? And then I've got 2 times -2 minus 2, and then 0 minus 4. I'm changing out the y values and I'm changing out the x values based on the ordered pair that's been given. And we end up with -6, -4. And I know that connecting these 2 dots should be a straight line. So -6, -4. There it is. So tomorrow you're going to have a function. You're going to be given the transformations like y is equal to, 3f. I won't have the b-value factored out, and you're going to have to come up with a new function by mapping every ordered pair. So this becomes 2 times 0 minus 2, and then 8 minus 4. So -2 and 4. And then again, I connect the dots so I know how they're supposed to be connected. It was supposed to be a straight line. I can see from my original it was a connection of a straight line. And then I'm back to the next one. And if you're not getting the same shape, just wider, then you're going to be in trouble. You know you made a mistake. So 2 times 3 minus 2, and then 0 minus 4. I'm just going to come up with these last two. So 6 minus 2, which is 4, and negative 4. And then I've got 2 times 4 minus 2, and then 4 minus 4, which gives me, this is 8 minus 2, which gives me 6 and 0. So rather than kind of like performing each of the transformations one at a time on the grid, I just perform the mapping, and it's the same rule for all of them. My 4 and negative 4 and this is the order of pair I missed, right? Negative 2 and 4 I've got. 4 and negative 4. So 4 and negative 4 is right here. I connect it by a straight line. Oh, that's not straight, but you guys get it, right? Like, you guys would do a better job in your paper. And then I've got my 6 and 0. Does it kind of give the same vibe as the original graph? What can you tell that's different? I can see that it got twice as wide. You guys see that this graph is like, you count it out, it's like 7 units wide. If I count this guy out, it's 14 units wide. I can see that horizontal stretch by a factor of 2 from the y-axis. But if you set up the mapping rule, it's a game changer. Like, it's an absolute game changer. And then you can do the whole thing. Yeah? Okay. Now this one is tricky. There's going to be a question like this on tomorrow's quiz, so I want to get through this example. I know we might not get through task number 8, but I'm still checking this homework. Okay? I know it's a lot, but you signed up for a lot. Okay? You should have already done 1.1. You should have already done 1.2. You should have done your 10 a week. And I know it's a lot, but you signed up for a lot. That's what this course is. Okay? Now this is a really important detail. First of all, when you look at this, what's your B value? Like, before I interpret domain and range, what's the B value here that I should be recognizing? What is it? There's actually a 4 too, so you can't ignore the fact that there's a 4. Guys, your B value here is actually negative 1/4 x plus 2 minus 5. So the first thing you have to recognize is, what was the B value? The B value is supposed to be attached by multiplication, not division. And we can't ignore the 4 entirely. Did you guys see the negative 1/4 and how we obtained that? Pull the whole thing out, make it a coefficient. Now, can you see the horizontal translation right now? No, we need to see the 2 sets of brackets. So the next move is to divide each term by negative 1/4. Now, if your fraction operations aren't great, just type in positive 2 divided by negative 1/4, but just put brackets around your negative 1/4. If you take 2 divided by negative 1/4, that's the same as 2 multiplied by the reciprocal, and we get negative 8. So if you wanted to know, like, the mental math that goes into this, should you know that when you're dividing fractions, you're multiplying by the reciprocal? Absolutely. That's junior high. So g of x is equal to f. I start my square brackets. My b value was negative 1/4, and then I've got x minus h in the brackets, and then minus 5. What's my mapping? If I wanted to come up with a mapping rule here, what's my mapping? Remember, these two will change the x's, and then the outside's going to change the y. So my mapping rule looks like this. What's happening to my x's? Got it? What do you got? Did you try it? What's your name? Yeah. Okay. Pause with
-4.
perfect. Plus what? Plus 8. Thank you. Thank you. Are we good? Okay, guys. So this is my mapping rule. Now this is where it makes the question a little bit more interesting. Is it didn't give us an ordered pair. We were actually given a domain and range and interval notation. So when you interpret the domain, this is an x value, and so is this an x value. So if the domain of f of x, Guys, you don't need to put stuff away yet. You need this. It's gonna be on your quiz tomorrow. If the domain of f of x is -2 to 5, that means one x value was -2 inclusive, the other x value was 5 inclusive. We can map these two x values according to this mapping rule. If I take -4 times -2
Good morning, everyone.
and then add 8,
Can you please stand for the praying
we'll
of
get
the Angelus?
16. I guess we'll stand now. So in terms of